Hi guys, today we're going to continue chain rule, but today we're going to include chain rule with product and quotient rule involved. As far as the big ideas go, the biggest thing is just you should still be working on memorizing all of our derivatives. Okay, so looking at number 1, we have a product. Product rule says derivative of the first, but in order to take the derivative of this first piece, I'm going to need to use a chain rule. So I'm going to have to define my u, which then makes my fu, u to the 5th. I'm going to take the derivative of each of those pieces. And then I'm going to multiply those together. So 8 times 5 is 40. U to the 4th. So that's the derivative of the first. Keep the second. Plus, keep the first. Times derivative of the second, but I run into the same issue. When I go to take this derivative, I'm going to need a chain rule. And then only because I'm weird and I don't like having that number smashed randomly in the middle, I'm going to rewrite my problem just to make it look a little bit nicer. Okay. All right, so there is a product rule with a chain rule. Okay, number 3 is very similar. I think you guys can do that one on your own just because I want to try and keep this video fairly short. Let's look at number 2. Here is a quotient rule with a chain rule. So quotient rule says derivative of the first, but again, in order to take the derivative of this first piece, I'm going to need a chain. So I'm going to pick u to be 4x plus 2, which means fu will be u to the 5th, and I'm going to take the derivative of each of those. Okay, so that would give me 20 u to the 4th, but my u was 4x plus 2. So there's my derivative of the first. Keep the second. Minus, keep the first, times derivative of the second. All over the second squared. Okay, so I'm looking to see if there's anything I can cancel. No, so I can clean this up just a little bit. And really, by cleanup, I didn't really do anything except just kind of move some stuff around just to make it look a little more aesthetically pleasing, but okay. All right, I'm a liar. I'm going to go ahead and do number 3. I said I wasn't going to, but I'm going to. All right, again, it's a product rule with chains. So derivative of the first, I'm going to have to pick a u and an fu. And I'm going to take the derivative of each of those. Okay, I have to multiply that back together. So I've got 9u squared, that'd be 3x minus 4. So that's the derivative of the first times, keep the second, plus, keep the first, derivative of the second, but I need a u again. And when I multiply those together, I would have 6 times 1 over u, but u was 6x minus 2. So again, on the first, oops, sorry, don't know what I hit there. First half, there's really nothing I can do to make this look any nicer. But on the second half, because I have times a fraction, these are all being multiplied together anyways, the multiplying fractions, I go straight across the top, straight across the bottom. So I could rewrite this as 6 times 3x minus 4 cubed over the 6x minus 2. Again, it didn't really get rid of much, but it just makes it look a little nicer. Okay. So now for number 4. Okay, and I'm going to try and give myself some boundaries here just because this one's a little lengthy in that. Yes, I have a quotient rule because I see the big division sign, but I also have a product rule mixed in with my chains. So I'll try and talk nice and slow through this one, and I'll pause as much as I can, but you can always pause your video, obviously. So quotient rule says derivative of the first, but my first is a product. So to take the derivative of the numerator, I have to also do a product rule, which says derivative of the first, keep the second, plus keep the first times derivative of the second, but in order to take the derivative of this, I need a u. Take their individual derivatives. Okay, so then I'm going to have this times 6u squared, and u was 2x plus 5. Now, sorry to tell you, all of that was just the derivative of the numerator. Quotient rule says derivative of the numerator, that was all this big mess that I wrote in brackets, times keep the denominator, minus keep the numerator, times derivative of the denominator. But in order to take the derivative of my denominator, I need another u. And I'm going to take the derivative of each of those. And I'm going to multiply that together, so that make 20u cubed, and u was 5x minus 1. All of that over the denominator squared. Whew, big mess. All right, so kind of maybe clean up just a little bit. Okay, in this big long bracket, there's not a whole lot I can do because there's pluses and minuses involved, but I can at least take the 6 times the x squared. I know that sounds a little like whoop-de-doo, but okay, so now I have all that times 5x minus 1 to the 4th minus, really not a lot I can do here. I guess I can put these two things together, makes it look a little nicer. 20x squared, and I got 2x plus 5 cubed, 5x minus 1 cubed, all over 5x minus 1 to the 8th Now, a thing that you all need to start trying to train yourself to see a little bit is there's a lot of junk going on, but do we see something in common? And I hope you're all saying yes. This 5x minus 1, I see it in all three locations. So I can cancel some of those. I have 5x minus 1 cubed, 4th and 8th, so I can get rid of 3 of them, which would leave me 1 here, 5 here. So now I have 2x times 2x plus 5 cubed plus 6x squared, 2x plus 5 squared, all of that times 5x minus 1 minus 20x squared, 2x plus 5 cubed, all over, and I know I'm kind of squeezing this at the bottom of the screen. I apologize. That to the 5th power. Okay? Chain rule with product rule. I'm sorry, guys. The biggest thing with